All right, let's take a look at the applications of quadratic equations. Basically, these are word problems that involve solving a quadratic equation that we've been working with in the first three sections of this chapter. All right, and we can solve them by what? By taking the square root of both sides, by completing the square, and also by what? Quadratic formula that we saw last time. Okay, then. Now, this is a very short section, so let me just. So there's really no new material here except if you're given a word problem, you want to be able to set it up in a quadratic equation and then finish solving it. All right. So let's start with let me work out a few examples for you, and then that's all we're going to have, and there won't be any problems to pose into the discussion area in Blackboard here. Okay. We'll go over the word problems more in class in detail. All right. Let's go ahead and look at some problems here. So let me go ahead and do that. We've actually solved some of these problems before by factoring, of course, but now we may use the completing the square or the quadratic formula technique. All right. So let's look at this example right here. All right. So let's start with the basic example here. This is fair game on the final exam, for example. All right. So it says what? The height of a triangle is twice the length of the base. The area of the triangle is 36 square meters. Find the height and the base of the triangle. So pretty standard problem, right? So let's make a quick picture here. So here's what's happening in the problem. So I have some triangle here. All right. So let's have some triangle here, like this. All right. And it says what? The height of the triangle is what? Is twice the length of the base. So let's say but I don't know what the base is, right? So let's make that x. But the height I know is going to be twice that. So 2x. Can you see that? And the area of this triangle is what? 36 square meters, or just 36. All right. So do we remember the formula for the area of a triangle? Well, area of a triangle, remember, is what? Half the base times the height. Are you with me on that? Okay. So let's do that. Let's plug it in. So again, what's the area? The area is what? 36. So it's going to be 36 equal to 1/2 the times the base. Base is what? X in this case. So times x. All right. Times the height, which is what? 2x, right? The height is what? Twice the length of the base. So 2x for the height. So times 2x. Again, 36 area equal to 1/2 base, which is x, times height, which is 2x. All right, are you with me on that? Make sure we see that. Well, that's a nice simple equation. Apologize for the phone interruption there. Where we leave. Okay, so we left off with this equation here, right? Area is 1/2 base times height for the triangle, all right? And we said what? The height of the triangle is twice the base, all right? So there it is, right? So 1/2 times the base, which is x, times the height, which is 2x, right? And the area is giving us 36 square meters. So we're solving this standard quadratic equation. Not too bad. Let's go and work it out first, though. So we get 36 is equal to what? Is equal to, well, the 2's are going to drop off here. Can we see that? So I get x squared here, all right? And I'm going to take the square root of both sides again. This time, again, since I have a perfect square, right? I can use that technique. We have from 11.1. So I get x is equal to what? Plus or minus what? What's the square root of 36? 6, all right? Can we see that? All right? But I want you to observe something here. So x is plus or minus 6, right? But let's observe that x is what? X is the base of a triangle. The base of a triangle, the measure of the a side of a triangle cannot be negative. Can we see that? So therefore, the negative answer is not valid here. All right? Can we see that? So the answer is just 6, if you will. In other words, we're saying the base of this triangle is just going to be positive 6 meters, and the height of this triangle is going to be twice that, which is going to be what? 12 meters. Can we see that? So this is the solution we're looking for in this problem here. All right? Let's go ahead and try another one here. Let me go and clear out the screen again. Nothing new here. Just applying your quadratic equation knowledge, solving of quadratic equations knowledge here to solving these word problems here. Okay, let's go and clear out the screen. Let's go and look at another one. Let's try this one. Okay, let's look at this one here. The sum of the squares of two consecutive positive even integers is 52. Find the two integers. All right, so we're talking about two consecutive, positive even integers, all right? First of all, what is two consecutive even integers anyways? Well, remember that? n plus 2, if you remember the general expression for two consecutive even integers, right? In this case, they're both going to be positive, so keep that word positive in mind. All right, let's go and solve this problem here. So it says what? It says the sum of the squares. Now, what does that mean, sum of the squares? That means what? You're going to square each of these guys and then you're going to sum them up, right? Sum of the squares, right? So that means square each of these numbers, so n squared plus sum, right? N plus 2 squared, right? Sum, again, sum here, sum of the squares is equal to what? 52, okay? Again, is means equal, right? Recall that. All right, let's go and solve this equation. So we have n squared plus, again, let me square this out. That's going to be what? N squared plus 4n. Remember how we got that? Multiply a and b together. N times 2 is 2n. Double it, 4n, all right? Plus what? B squared, 4 equal to 52. Again, using the formula to square this out. Square out this binomial. Hopefully we can see that without too much trouble here. Combine like terms. N squared is what? 2n squared plus 4n plus 4 equal to 52. Are we good on that? All right. Let's go and divide everything. Now in this case here, we can see that what, before I factor it, we can see that all the terms here have even numbers in them. So let me divide by 2 here to simplify my number. I'm just trying to make my number smaller, right? Divide everything by 2. Divide both sides by 2. So 2's drop off. I get n squared plus what? 2n plus 4 over 2 is what? 2 equal to 52 over 2 is what? 26. All right. So let's go ahead and solve this. Let me try to solve this by factoring. Let me get the right side of the 0. Let me subtract 26 on both sides here. Okay. Again, we can solve by what? Factoring, by completing the square, by taking the square root of both sides, by quadratic formula. So there's 4 techniques here, right, involved. But let me use factoring first, since that's the one we're used to. That's the easiest one of all. So we get what? We get n squared plus 2n minus what? 24 equal to what? 0. All right. Let's factor that. This is factorable. This factors to n plus 6 times n minus what? 4, if you remember the factoring of this type of trinomial back in chapter 8. 2 numbers that multiply to negative 24 add up to positive 2, positive 6, negative 4. Hopefully we can see that. So therefore, we set the factors to 0, right? So n is equal to what? Negative 6 for this factor. Okay, imagine setting n plus 6 equal to 0. When you subtract 6 to both sides to solve it, yeah, just to get negative 6. Here, if n minus 4 is 0, then just add 4 to both sides, so n is equal to what? Positive 4. All right. So what are my 2 numbers then? Well, these aren't my 2 numbers here. My 2 numbers should be what? 2 consecutive what? Again, positive even integers. All right. So therefore, it's going to be the positive even integer here. So it's going to be 4 and what? n plus 2. 4 plus 2 is what? 6. 4 and 6 are my solutions here. In fact, let's check our answers real quick. Let's look at the sum of the squares of these 2. What is 4 squared? 16. What is 6 squared? 36. Is that 52? Yes. All right. So these 2 numbers are the solutions we're looking for. 2 consecutive positive even integers. All right. Make sure we see that now. Suppose we ask for 2 consecutive negative even integers. Then it'll be what? It'll be the negative 1, and so it'll be negative 6 and what? Negative 4 in that case. Okay. But again, we're only asking for the positive ones in this case. Let's go and try another one here. Again, all we're doing is what? Turning these word problems into a quadratic equation, which we can then solve by one of the techniques we've seen in the past. All right? And let's go and clear out the screen. Now, let's look at this problem right here. Okay, so here's a challenging problem for us. It took a boat 2 hours longer to travel 90 miles against the current than it took to travel 90 miles with the current. All right? So going against the current, we took 2 hours longer to go the same distance here, 90 miles, that is, right? The rate of the current was what? 6 miles per hour. So I want to find the rate of the boat in calm water. All right, I'll call that R. Let's let that be R, rate of the boat in calm water. Okay, let's call that R. And remember the table setup we used back in 9.7. Let's use the same table there since the 2 distances are given to us here. All right, so let's make a big table setup here. And remember a table setup here. It has 3 rows in it. First of all, all right, and here we have the formula, which is distance, all right? If you remember, divided by the rate is equal to what? The time. This is from 9.7 homework, all right? So check the section again if you need to on 9.7, all right? But what are two situations we're comparing? Well, against the current and with the current, all right? So let me say against, all right, current, okay, and with current. So going against the current, going with the current. Okay, can we see that? All right. Now, what are the 2 distances? Well, 90 miles, 90 miles. So 90 against, 90 with the current. All right. What about the rate? What do we know about that? Well, it says what? The rate of the current is what? 6 miles per hour. But I don't know what the rate of the boat is in calm water. In fact, that's what we're trying to find out. What is the rate of the boat in calm water, right? So, but again, we're saying that's R. Now, if you're going against the current is slowing you down. So it's going to be what? R minus 6. Can we see that? If you're going with the current is helping you out. So your R speed is going to be R plus 6. All right, make sure we see that. All right. Let's get the time for each situation. So time against the current is what? 90 over R minus 6. Again, distance divided by rate is time. So divide these two to get the last column here. And the time with the current, 90 over R plus 6. Can we see that? Now comes the challenging part. All right. He says what? It took a boat 2 hours longer to travel 90 miles against the current than it took to travel 90 miles against the current. With the current. So against the current took 2 hours longer than with the current. Can we see that? All right. So what does that mean? That means that the difference of the two times will be 2 hours. Can we see that? Again, which is the longer time? Well, against the current we took longer, right? With the current we took less time, right? So in other words, against the current's time, so the time against the current, in other words, I'm saying this, I'm saying 90 over R minus 6, all right, against the current, that's the time against the current, minus the time with the current, 90 over R plus 6, is equal to this 2 hour difference here. Can we see that? Again, if it says it took a boat 2 hours longer to travel 90 miles against the current than it took to travel 90 miles with the current, that means the difference of their times will be 2 hours. Can we see that? All right, hopefully we can see that, but again, read this problem over and over again if you need to. Again, it does take some thought. You have to think about it a little bit, all right? But that's the equation we come up with, nevertheless, all right? Now, let's solve this equation. Let's get rid of fractions by multiplying both sides by the LCD. What is the LCD in this case? Well, it's going to be R minus 6, R plus 6. We solved these equations before back in chapter 9, right? So let's multiply everything by R minus 6, R plus 6, all right? So I'm going to have R minus 6, R plus 6, the LCD, times the first fraction, 90 over, excuse me, R minus 6, and then minus R minus 6 times R plus 6, again the LCD, times the second fraction here, 90 over R plus 6, all right, equal to 2 times R minus 6, R plus 6, again, that's my LCD. Once again, so I'm multiplying the LCD to all three things here, all three terms, right, here, here, and here, all right? Now, let's simplify that. So here, R minus 6 is drop off. Can we see that? So I get 90 times R plus 6. Let me continue here. 90 times R plus 6, all right? Here, the what? R plus 6 is drop off. Can we see that? I get minus 90 times R minus 6. So minus 90 times R minus 6, all right? Equal to, here, what I get? Well, 2 times R minus 6, R plus 6. Let me first multiply out R minus 6, R plus 6. Isn't that A minus B? A plus B, difference of two squares. So isn't that 2 times R squared minus 36? So you can figure that out. Review a little bit from chapter 7 to see that R minus 6 times R plus 6 is R squared minus 36. Hopefully we can see that without too much trouble here. All right? Let's continue simplifying this equation here. Again, after I've multiplied by the LCD, there's no more fractions here. This becomes a simpler equation to solve. Let's go and finish it though. So 90 times R is 90R. 90 times 6 is going to be what? 540. Negative 90 times R, negative 90R, excuse me. And then negative 90 times negative 6 is positive 540. Equal to what? 2R squared. 2 times R squared is what? 2R squared there. 2R squared, and 2 times 36 is what? Minus 72. Okay, sorry for running close to the edge there. Okay, well, combine my terms. 90R minus 90R, cancel out. 540 plus 540 is what? 1080, equal to 2R squared minus 72. Are we good on that? All right. Let me go ahead and isolate this perfect square R squared here. Let me go ahead and add 72 to both sides. Okay, that takes care of that. So that gives me what? What is 1080 plus 72? That's 1152. I hope you get that. I just punched it into a calculator or add it by hand. No big deal. Equal to 2R squared. Now divide both sides by 2 to isolate the perfect square R squared completely. All right. So what is 1152 divided by 2 on the calculator? Let's see. We get 576. So we get r squared is equal to 576. All right. Now what? Take the square root of both sides here. Okay. So we get, let me continue here. I get r is equal to what? Plus or minus what? Square root of 576 is what? 24 in the calculator? 24. All right. So that is a perfect square. Good. All right. Now, again, r is what? R is the rate of the boat in calm water. Of course, the speed cannot be negative, right? So we can eliminate that. So therefore, the final answer is going to be r equal to what? 24 miles per hour. This is the speed of the boat in what? Calm water, meaning when there's no current, the boat can go 24 miles per hour. So this is a very challenging problem, as you can see, right? We get 24 as the solution up here. Okay? All right, very challenging problem here. That's the rate of the boat in calm water once again. Again, how do we set it up? We use this table here, distance divided by rate is equal to time. We fill out one column at a time, and then we get the equation. And this equation is challenging because it says it took the boat 2 hours longer to travel 90 miles against the current than it took to travel 90 miles with the current. That means the difference between those two times is what? 2 hours. Can we see that? That's why I can take the difference of these two times equal to 2. All right, and then finish solving the equation by multiplying both sides by the LCD to get rid of fractions. I get this nice easy equation here. Then I simplify each side, all right, by distributing, and then getting the r squared term by itself, and then taking the square root of both sides. And I have my solution. Again, the rate of the boat cannot be negative, so we can eliminate that. We get our solution here, 24 miles per hour. All right, let's do one more, and then we'll just wrap it up. Let me go and clear off the screen. All right, let's try this one. All right, here's a word problem for us. It says what? A tank is emptied by 2 drains. The smaller drain can empty the tank in 3 hours more than, sorry, let me read again. The smaller tank can empty the tank in 3 hours more than it takes the larger drain to empty the tank. Using both drains, the tank can be emptied in 2 hours. How long would it take the larger drain working alone to empty the tank? Remember this table here? Let's set it up. Let's make a nice big table here. If you remember from 9.7 homework, all right? Let's make a table with 3 rows in it, okay? A few columns here, all right? Now, remember I threw in one more column, the time alone, remember that? This is the time to get the work done if each of the drains worked by themselves, worked alone, right? In fact, that's what we're being asked here. How long would it take the larger drain working alone, right, to empty the tank, right? All right, so time alone column. And then what do we have? We have the work rate. I'll write it in work rate, all right, times the time worked, or just times time, how much time you put into the job, equal to how much of the job you complete. Part of job, sorry about that, part of job completed. Okay, part of job completed. All right, remember this equation here from 9.7 homework. All right. What 2 parties here are work? Well, we have the small drain and the larger drain. So small drain, all right, and large drain, larger drain. All right, so again, it's hard to fit into the table here, but do the best you can. All right, let's look at the time alone. So it says what? It says the smaller drain can empty the tank in 3 hours more than it takes the larger drain to empty the tank. So we know the smaller drain takes 3 hours longer than the larger drain. But I don't know how long the larger drain takes by itself. So let's let that be T. The smaller drain is going to be what? T plus 3 because it takes 3 hours longer. Are you with me on that? All right. Okay, what's the work rate? Well, work rate is just reciprocal of how long it takes you to do a job working alone, right? So 1 over T plus 3 for the small drain, that's the work rate. Work rate for the larger drain, 1 over what? T. Can we see that? All right. How about the time worked? Well, it says what? Using both drains, the tank can be emptied in what? 2 hours. So if each drain is open for 2 hours, job gets done. So 2 hours here, 2 hours here. Can we see that? Working together, right? All right. So using both drains, that means working together. So how much does each drain complete then? Well, let's see. Multiply to get the last column, right? Work rate times time is equal to part of the job completed, right? So 2 over T plus 3 is the part completed by the small drain. 2 over T is the part completed by the larger drain. But together, they what? Complete the entire job. So we have 2 over T plus 3 plus 2 over T is equal to what? 1. The 100% of the job, the entire job. Again, check the 9.7 section if you need to on that. All right, then let's go ahead and multiply by the LCD. LCD is what? T times T plus 3. Hopefully we see that without too much trouble here. All right, so multiply everything by T plus 3. All right, so here it is. T plus 3 times the first fraction, 2 over T plus 3. All right, plus T plus 3 times the second fraction, 2 over T. All right, equal to 1 times T plus 3. Again, I'm multiplying T plus 3 to everything. Can we see that? All right, let's work it out. So T plus 3's drop off here, so I get what? Let me continue up here. I get 2T, all right? And so I get 2T once again, right? And then here, the T's drop off. Can we see that here? I get 2 times T plus 3. 2 times T plus 3. I'll do step by step there. All right, 2 times T plus 3. And then 1T times T plus 3 is just going to be what? T times T plus 3. The 1 drops off, right? Invisible 1. All right, let's work it out. Simplify. 2T plus 2 times T is what? 2T again. All right, 2 times 3 is going to be what? 6. All right, equal to T times T is going to be what? T squared. T times 3 is going to be 3T. All right, are you with me on that? Okay, then let's go ahead and combine like terms. 2T plus 2T is what? 4T. I'm just solving this equation, right? This is what the word problem part is over once I fill out this table and I get this equation here. Can we see that? So 4T plus 6 is equal to T squared plus 3T. All right. Again, let me try to solve this by factoring. Here's the T squared term on the right side. Let me zero off the left side. Let me minus 4T on both sides. That takes care of the 4T's, right? Let me also minus 6 on both sides to take care of the 6's here on the left side. So 0 is equal to T squared minus T minus 6. Are you with me on that? All right? So this is factorable. This is going to be what? T minus 3 times T plus 2. Again, make sure we see the factoring on that, all right? So therefore, T is equal to what? Positive 3 here and negative 2 here, right? Remember, if I set these to 0, that's what I get from my solutions, right? But again, time, T is the time it takes the larger drain to get the job done working alone. That's what we're trying to find, is that, right? How long would it take the larger drain working alone to empty the tank? That's what I'm trying to find, all right? So that is the answer. Now, is it positive or negative? Well, time cannot be negative, so ignore the negative answer. Can we see that? So the answer is what? Is 3. In other words, we're saying the answer is going to be 3 hours. All right, it takes the larger drain 3 hours working alone to empty this tank. How about the smaller drain? Suppose I ask you about a smaller drain on the exam. Well, it says what? The smaller drain takes what? 3 more hours than the larger drain. So T plus 3. 3 plus 3 is what? 6 hours in that case, right? But again, here we're just being asked for the larger drain. So I'm good on this answer right here. Okay, can we see that? So okay, let's take a look at the 3 problems we have for you for this section on the applications of quadratic equations here. All right, so number 1, solve these 3 problems. So number 1, the length of a rectangle is 1 less than twice its width. If the area is 120 square inches, find the dimensions of the rectangle. All right, so find both the length and the width of the rectangle. All right, number 2, an older computer requires 12 minutes longer to print the payroll than does a newer computer. Together, the computers can print the payroll in 8 minutes. Find the time for the older computer working alone to print the payroll. So typical work problem there. All right, let's take a look at number 3. A car travels 200 miles. A second car traveling 10 miles per hour faster than the first car makes the same trip in 1 hour less time. Find the speed of each car. So use the uniform motion concepts there. All right, so pose these 3 problems in terms of their solutions into Blackboard. Okay, take care now and have a good day.